Hello everyone. Today we are presenting our project on the IP security policy implementation, which focuses on controlling and securing network traffic. In modern networks, data is constantly transmitted between the device, and not all of these traffics can be trusted. Without proper control mechanism, networks become vulnerable to unauthorized access and attacks. Our project simulates how security policies are used to filter and manage this traffic effectively. This work is a part of our cryptographic and network security course, and through this implementation, we demonstrate how firewalls like rules can be applied to ensure secure communication. Now, let us understand why restricting network traffic is important. In any network, allowing all the traffic without restriction is a major security risk. IP security policies define rules that control both incoming and outgoing traffic. These rules are based on three main factors. First, IP based filtering, which checks whether the source or a destination IP is trusted. Second, port and protocol logic, which ensures that all the specific services like web or DNS are allowed to operate. For example, web traffic typically use port 80, secure shell uses port 22, and DNS uses port 53. By controlling these parameters, we can ensure that only traffic is allowed while blocking suspicious and or unauthorized access.
In our implementation, each security rule acts like a digital checkpoint. We define a rule using four main parameters: IP address, port number, protocol such as TCP or UDP, action which is either allow or deny. In the code, this is implemented using a class called rule. Each rule object stores these values and represents a single filtering condition. This structure allows us to easily define multiple rules and apply them to incoming packets. Now let's understand how the rules are organized and applied. The rule architecture defines how packets are evaluated against the security policies. Each incoming packet contains source IP, port number, and protocol. In our code, we use a function that checks each packet against all defined rules. The comparison includes exact matches and wildcard matches using any. For example, if a rule contains any for IP or port, it means that field will be match any value. If a packet matches a rule, the corresponding action is applied immediately. If no rule matches, the system follows default policy, which is deny. This ensures that unknown or suspicious traffic is automatically blocked.
In our implementation, we defined a set of rules to simulate the real-world scenarios. For example, traffic from 192.168.1.10 on port 80 using TCP is allowed. Traffic from 192.168.1.20 on port 22 is denied. All DNS traffics on port 53 using UDP is allowed. These are rules processed sequentially. The first rule matches a packet determines its action. This means rule order is very important as it directly affects the traffic is handled. Now let us move on how we test these rules. Packet simulation. We test our implementations. We simulate different types of network packets. Each packet contains an IP address, a port number, a protocol. We test multiple scenarios such as web traffic on port 80, SSH access on port 22, DNS queries on port 53, external traffic on port 443. Each packet is passed into the validation function, which checks it against the defined rules. This allows us to observe how the system behaves under different conditions.
Now we look at the execution output of our program. Here we can see how each packet is evaluated based on the defined security rules. For each packet, the system prints whether it is allowed or denied. For example, a packet from the address 192.168.1.10 on port 80 using TCP is allowed because it matches our web traffic rule. Similarly, a packet from 192.168.1.20 on port 22 is denied as per our security restriction. DNS traffic on port 53 using UDP is allowed. Any unknown traffic, such as external traffic on port 443, is denied by default. This output clearly demonstrates how the rule engine processes packets in real time. This is exactly how real world firewalls filter and control network traffic. Coming to the conclusion part, our implementation shows how IP security policies act as a first line of defense in network security. We demonstrated how rules are defined using IP, port, protocol, and action, how packets are validated against these rules, and how unauthorized traffic is blocked. This system provides protection by preventing unwanted access, precision by targeting specific traffic conditions, controlled access by allowing only trusted connections. Through this project, we gained a practical understanding of how firewalls and network security systems operate. Thank you.